In this video we're going to look at the design of earthworks for a road. This is what you need to know to do assignment 1. We're doing assignment 1 using the manual methods because that gives you a good idea of how a computer actually does it. In reality you'd probably do it all with a computer, but you need to know what the computer's doing, you need to know the methods that are going on so that if something goes wrong, if something's not right, you'll actually pick it up rather than just entering data and getting the wrong result. So it's important that you understand what's actually going on with the road design process. So here's our route that we're looking at. Remember we did this in class, we all went out and had a bit of a look at this piece of Unitext. So there's a road there, there's the business school, and remember we had to design a road going from here to the entrance 3. Looking at this, I've decided that the way I'm going to do it is I'm going to take it along from this end of the road, and I'm going to take it around. I don't want to bowl this historic wall here, so I'm going to take it around then up there. So what I do is I draw my lines there. These green lines show the straights of it, and what I'm going to do is I'm going to connect these straights with curves, which is what I've done here. So that's what that red thing shows, the center line of my road. Notice that these curves here have to be greater than the minimum radius. So in class we had some tables that showed what the minimum horizontal curve radius was. I've just drawn these in yellow to make sure that my curves are actually greater than that radius. This curve here is getting a bit close, so I might, if I was doing it again, I'd probably make that a little bit wider, bring it around like that, but let's just go with what we've got. And I also like to draw the road on just to get a feeling for the extent of the work, the scale that I'm working with, to make sure that I'm not sort of going too close to anything. Now what we're going to do is we're going to put some chainage on. Remember, chainage is the distances along the center line. In this case we're going to use a chainage distance of 20 meters. In your assignment you'll be using 40 meters. So I start at the 0 point at the start of the works and I do a 20 meter curve circle, and I end up there. So we're the 20 meters along. So what I'm trying to do is to find 20 meter distance along here, 20 meter distance along here. So the way I'm doing it is I'm just drawing circles, 20 meter circles, 20 meter radius circles around, and I end up with these points here, which are my chainage points. And the chainage starts at 0 and then sort of builds up. So this point here is 160 meters along distance from 0. Going along the line of the center line. Before we go much further, let's look at the contours here. Notice that we've got bold contours, the main contour lines, 25 and 30, and we've got a whole lot of little ones in between. Notice that there are 10 of these lighter contour lines between 25 and 30. We know that the horizontal distance between these two lines is 5 meters. So it's 5 meter vertical distance between them. So therefore each one of these is a half meter rise. So that's 25, 25 and a half, 26, 26 and a half, 27, 27 and a half, and so on to 30. We can also see that it's dropping from here, so there's a steep bank going down to there. So you should be able to read these. Looking at our road, we're going along, it's sort of flat, goes along. There's a bit of a knoll here, and then it starts getting real steep down here, and then it flattens out and goes around like that. So we should be able to look at that and say, okay, well, it's going to get steep here and it's going to shallow. So when we're doing our long section, we'll be checking that to make sure that that is actually what it shows. Now we're going to do the long section, and the way we do that is that we mark where the contour lines cross our road center line. And we mark out the points. So this yellow marks here are the chainage distances where the crossing happens. So the 28 meter contour crosses at 19 meters chainage. So 19 meters away from 0. The 27 meter contour crosses at chainage 35 meters from the 0 point. So with all this information here, we can do a straight line showing the ground profile, which is what we've done here in red. So each one of these points is one of those sets of numbers that we had on the plan. So you can see what we talked about before. It goes nice and flat. There's a bit of a drop there, it flattens out, then there's that knoll drops down, and it goes like this. The next thing we do is we draw on our road, and in this case we need a nice even curve. So I've got a bit of a straight here, I've got a vertical curve, and remember I make sure that my vertical curve is bigger than the minimum allowable vertical curve allowance. Then there's a bit of a straight down here, then there's another curve as I'm curving up to start going up that hill again. Notice also that I've put some additional lines in here where the topography changes. So at this point here it stops being a steep slope and starts flattening out. So I need to pick up this point here. At 88 likewise it's going nice and flat, and then it starts dropping away really quickly. If we didn't put an additional, and these are additional cross sections, so if we didn't put an additional cross section here, the model that we've got, which is what we're doing a model, would show that the ground level went from here directly down to there, straight line, and it would miss all of this cut volume there, which is not good, and it's totally inaccurate. So we'd put this 88 this additional cross section in at 88, so that when we're doing our calculations we're not missing it. The other place where you need to be putting an additional cross section in is where the cut and fill finish. So here we've got a whole lot of fill, and we've got some cut. So at about chainage 60 the cut and fill are 0, which is nice and convenient because it means we don't have to put another cross section in. But if the cut and fill crossed here, for example, we'd need to be putting another cross section in there to make sure that we're making it properly. If the cut sort of conks out in one area and the fill conks out in another, then you need to be putting in 2 cross sections. So where there's a cut stopping or a fill stopping, you need to be putting in an extra cross section there, and that is all to make sure that you are making an accurate model of what the ground looks like. Notice we've got this table down here: formation level, ground level, cut and fill. Forget about these negative marks, these should all be positive. That's just a glitch in the program. So they're all positive, and all they do is they just show the distance between there and there. So it's 0.7 meters distance between there and there. Now we've got our long section, now we're going to do our cross sections, and the way we do that is much the same as we did with the long section, but this time we draw some lines that are perpendicular to the line of the road. So there's the road line, and then we're perpendicular. These ones on the curve, they are perpendicular to the tangent at that point there. Because this is a circular curve, all of these things all meet together at the center of this curve here. What we do is we also show where on these lines we show where the contours cross them. So we get these little lines here with marks showing the distance from the center line to those marks. Now for these cross sections, the center line is 0. Now you don't normally have the plan and the cross sections on the same bit of paper, but we're just doing this to show it, and we certainly don't have the long section in there as well. So these are the bits of information that you need to do the cross section. So let's look at the 0 and the 20. So we take this line here that we drew here, and then we rotate it, copy it and rotate it, and draw it there. So this 28 here is that 28 there, that 25 is that 25 there. Notice the orientation is the way the orientation works. The way you orientate it is, if you are standing on a point, you're looking up the road, in other words you're looking to the higher chainage numbers, that is the orientation. So in this case we're standing on 20, we're looking towards 40. If we were doing that, to our right would be this gully. So we're standing on 20, we're looking towards 40, on our right is the gully. So you need to make sure that you get the orientation right. Likewise, these points here, so the 28.5, we just carry it up onto that point there, and you carry on to get these shapes here. Notice that what we've got here is this scale here is different from the scale here. The scale here is 1 to 100, the scale here is 1 to 1000. So it's a distorted scale, which means that the slopes all look steeper than what they are. So that would be if it was an equal scale, that's what the slope would actually look like. With a distorted scale, it looks like that. So this slope here is actually like that in reality. The reason why we do the distorted scale is so we accentuate that vertical lengths, and it makes it easier to do the design. So we've got all our points here. From that we just lift them all up, and we also get our mid center point from the scale. Oops, we'll just go back a bit. Once we've done that, we can put the road in. We know what the road centerline point is from our long section, so we put our road centerline point in, and then we draw the road on to the edge, and then we connect the edges up to the existing one. So in this case here we've got a very small, the edge finishes there, and then we've just got to do a little bit of a cut there. It's a 1 and 2 slope in this case, so see I've got my distorted scale here. It looks steeper than what it really is. So this is what we end up with our cross sections. So you can see that 40, 60 and 80 all ended up right. So what we're going to do is we're going to look at this 40 and this 60, how we did the areas. So you will have done these on graph paper, and there will be a whole lot of little squares underneath. Okay, there won't just be these big squares, there'll be little squares underneath, so it'll look like that underneath your drawings. And we use those squares to calculate what the areas are. First thing we need to do is make sure we know what a square is. So each one of those squares is 1 meter across and 0.1 of a meter deep. So therefore the area of each one of those squares is 0.1 meters, 1.1 square meters. So the way we do it is, so we're looking at this fill area here, it's shown in yellow. We count every one of those yellow squares. Where you've got part squares, you just add them up. So you look at that, you say that's a third of a square, third of a square, third of a square. So those three make up one square. Those are 2 half squares, another 2, 3, 4. So you just make an estimate of it all. And we count that there are 58 squares. Each square is 0.1 of a meter square, 0.1 of a square meter per square. Therefore this area here is 5.8 square meters. Likewise, we measure this one here. We count 136 squares times 0.1. That is 13.6 square meters cut. So what you do now is that you put these into your table as the cut areas and fill areas at those particular points. You figure out the average area for each section. You times the average area times the length to get the volume for that section. You add the volumes up to get the cut and fill over the whole thing. You times the fill by the bulking factor, and then you do a cumulative addition to get the mass Hall diagram.